we're going to use y equals 1 over x as a guide to describe the transformation and graph each function. Y equals 1 over x, we need to know what that graph looks like. It is the parent function of all of our rational functions. There is a horizontal and vertical asymptote that cross at 0, 0. There's this branch on the left and the right sides. This one goes through 1, 1. This one goes through negative 1, negative 1. When we have an equation that is in this form, we can determine where the asymptotes cross by getting h and k. Those are our vertical and horizontal shifts. And the number on top, that tells us two different things. It tells us if there's a reflection over the x-axis or not. And it also tells us if we have a graph that is steeper, which would be a vertical stretch, or not quite as steep, which would be a vertical compression as compared to the parent function. So for letter A here, we are going to go through and take a look at g of x is equal to 1 over x minus 3. If you compare this function with the parent function is 1 over x. This is 1 over x minus 3. So the only thing that's different is this subtract 3 that is down here in the bottom. And our value for h there in the bottom would be actually equal to 3. If you have x minus a number, the number is your value for h. You do have to do a sign change there. There is no number out here for k. So if we identified what k would be, it would be an invisible plus 0 out on the end. So h is equal to 3, and k would be equal to 0. And our value is exactly like our parent function on the top of the fraction. It's equal to 1, which means we do not have a reflection over the x-axis because it's positive. And since it is the exact same number as the parent function, it is exactly as steep, the exact same size and shape as the parent function. So for our directions, we're supposed to describe the transformations that occur. Because our value for h is 3, that tells me that our transformation is going to be over to the right 3 units. That's the only thing. There are 4 different things that could happen. We could move right or left, we could move up or down, we could have a reflection, or we could change the steepness of the graph. Out of those 4 things, the only thing that's happening in this problem is that we are going to slide the parent function graph over to the right 3 units. So if I made a quick sketch of what this graph would look like, I would do this. The parent function graph has asymptotes that cross at 0, 0, but our graph has been moved over to the right 3 units. So if I start at 0, 0, and I go over to the right 3 units, that point right there, that is where the 2 asymptotes cross. So we have a vertical asymptote here at 3. The equation for that would be x equals 3. And our horizontal asymptote has not changed. It is still right on top of our x-axis, and the equation for that would be at y is equal to 0. And then from there, we want to draw in a sketch of the graph. Well, if you have a graph that has a 1 on the top, just like the parent function, there is a point here at 1, 1. So starting where the 2 asymptotes cross, if you go to the right 1 and up 1, you'll get a point that's on the graph. Same thing in the other direction. So to come up with a reasonable sketch for this, I am going to start here where the 2 asymptotes cross after we've done our horizontal and vertical shifts. And I'm going to go to the right 1 and then up 1. And then from there, I would draw in something with the shape of that function. If you were going to list this out, that is the point 4, 1. If you're using graph paper or whatever, or you're careful, it's pretty obvious that is the point 4, 1, but you could label that point also. And also in the other direction, so if we went left 1 and down 1, we would have the other part of this graph, which would look something kind of like that. And that is the point 2, -1, if you were going to take the time to list that out. So the directions were supposed to describe the transformation. Did that. And we made a very quick sketch of the graph by putting in the asymptotes using the horizontal and vertical shift, and then using the steepness of the graph, we came up with our points. For h of x, we're going to take a look at 3 over x plus 2, subtract 1. So taking a look at what's here in this problem, here are our transformations. We do have out here on the end a subtract 1, and down on the bottom of our fraction we do have a positive 2. This is our value for k, and it does not need a sign change, so k is -1, which will slide our graph down 1 unit. And our value here for h, we do need a sign change here, so h is actually equal to a -2, so we're going to be sliding over to the left 2 units. So as far as our vertical and horizontal shift goes, when we list those transformations out, we need to say down 1, we need to say left 2, and then this value for here up in the top, that's our value for a, and a is equal to a positive 3 in this problem. Because it's positive, there is not going to be a reflection. But the parent function is y is equal to 1 over x. We have a 1 on the top. This one has a 3. So this graph is going to be 3 times as steep as our parent function. Our book would say that that is a vertical stretch. Specifically, it's a vertical stretch by a factor of 3. Which just means our graph is going to be 3 times as steep. So one part of the directions is to list out any of the 4 possible transformations. This one has 3 of the 4. And then from there, we want to draw in and sketch a quick little graph. So using the idea of the parent function has its horizontal and vertical asymptotes cross at the point 0, 0. And we have a shift down 1 and left 2. Or if you take a look at h,k, that would give you that value also. So left 2, down 1. So right here, at the point -2, positive 1, that's where h and k would cross. So we have a vertical asymptote and a horizontal asymptote that cross at the point -2, -1. And then from there, we want to draw in our graph. The parent function has a 1 on the top. And from our cross, we go over to the right 1 and up 1. Our graph has a 3 on the top. A is equal to 3, so it's going to be 3 times as steep. So instead of going over 1 and up 1 to get a point on our graph, I need to make this graph 3 times as steep. So I'm going to go over 1 and then up 3. And then from there, we could draw in our shape. It does need to get close to the asymptote up at the top, and it would come down and go through our graph. If we wanted to, we could plug in some other values and see about what we would have. If you wanted to make this more accurate, you could plug in like 0 or 1 and get some more points with that, and that certainly would not be a problem. But it should look something about like that. On the other side, we want to do the same thing. So starting here at where our intersection of our horizontal and vertical asymptotes are, we usually would go over 1 and then down 1. But this has to be 3 times as steep, so I would go over 1 and then down 3. So that would be down about here. And then from there, draw in something that has that same type of shape that we would have before. So that would be a reasonable sketch. And again, if you wanted to make that a little more accurate, you could go through and come up with an XY table. For letter C, we have I of x is equal to a negative 2 over x plus 1. If you compare that to the parent function, we have a couple things that are different. One of them is the plus 1 on the end. So k in this problem is equal to 1. So that's going to slide our graph up 1 unit. And then our value here on the top isn't a 1 this time. It's a negative 2. So a is a negative 2, and that tells me two things. First of all, it's negative. So this will be a reflection over the x-axis. And it's a 2. So this graph is going to need to be twice as steep. So listing out our transformations, k is 1, so we're going to have to slide our graph up 1 unit. Down in the bottom we just have x, so there's no horizontal shift. Our value for a is negative, so there is going to be a reflection over the x-axis. And then also it is going to have a vertical stretch. It's going to be steeper. Specifically, it's going to be a vertical stretch by a factor of 2, meaning it's going to be twice as steep. So those are our transformations on this one. And then from there, we're going to need to go through and draw in our graph. Let's talk about the reflection first. So first of all, if you were going to take a look at a graph of the parent function, we know that that graph looks about like this. We have a horizontal and a vertical asymptote on the x and the y-axis, and then the actual graph looks like this. If you took this part right here and you reflected it over the x-axis, this part right here would reflect downward like this. So if we made a reflection and kind of folded the paper over there, this top part would get reflected down below here, and this bottom part would get reflected up above. So a reflected graph basically looks like those orange lines that are there. A reflected graph looks like that. It would still be over 1 and up 1, over 1 and down 1 for the parent function, but this needs to be twice as steep. So, rounding out all of that information, here we go. Here is a graph for the actual function for I of x. First, the parent function has two asymptotes that cross at 0, 0. I need to go up 1 unit for this. So our asymptotes cross here at the point 0, 1. The parent function, we would normally go from that point and go over 1 and up 1, but this one does need to be twice as steep, so I'm going to go over 1 and up 2, but instead of going up, I need to reflect it so it looks like this shape. So I'm going to go over 1, and I'm going to go downward because it's reflected, and I'm going to go down 2 because our value of a is a 2. Same thing on the other side. I'm going to go over and then up 2, and then from there we can draw in something that has the appropriate shape for our graph.